Okay, so this is a quick rundown of the log splitter attachment on the back of the backhoe. So normal old backhoe, and it's basically two main parts. This is the splitter attachment part essentially that holds the splitting wedge down here, and then we've got the movable jaw that replaces the traditional bucket on the bottom of the dipper stick. So this arm coming down here, that's called the dipper stick. This one's called the boom, just for some terminology. And then the linkage over here, you can see the hydraulic ram for the bucket doesn't act directly on the bucket because of the way it needs to be able to curl underneath. They've got a linkage set up here. So these are the side links, and as you look at that, they're just basically some standard heavy steel links. And then this one is called the H-link because it's got the bar inside, so it's shaped like an H essentially. So that's where they get their naming convention on it. So as the ram extends, it's partially extended right now, you can see that this part comes down and it'll eventually start to rotate horizontal like this. And as it rotates horizontal, you start to increase the mechanical advantage essentially of the ability to curl the bucket because your ram isn't forcing directly on it. Right now it's pretty close to a linear transfer of force onto that rotating arm. But as it starts to swing around, you can see the linkage will change its geometry. So the part that you're analyzing is the top link, which is this part right here. And so this is that standard farm part. And it's basically, its main job is to just hold the log splitter attachment in location. It works similar to a mechanical thumb, essentially, that you would maybe see on an excavator or backhoe, except for this one's just got a splitting wedge on it. And the adjustability on it allows us to simply rotate it, and then as you can see it will thread out on both ends and get longer. And then as it gets longer, we can change the angle of that splitting wedge a little bit. And so the adjustability on that is nice because if I'm splitting close to the back of the backhoe, like back here, you want the splitting wedge up higher so that the whole assembly can come straight down. And we can also rotate it further down if we needed to, depending on how we're splitting. Maybe we're splitting further up on a pile and we don't want it to be quite so horizontal. Maybe we want it a little bit more vertical. So it just kind of gives you a little bit of adjustability for splitting different size pieces. For the most part, I generally keep it set pretty close. So grand scheme of things, I built it to have adjustability. Probably didn't need to have adjustability. I think the primary cause of the issues though is when you land the link like this. This is the heavier model that you can buy now. This hole and going through here is basically in the worst possible spot because now every time that these have failed, they've always bent in this way. So this side is obviously on compression a little bit more on the column than this side is, and that puts the stress riser right at the maximum lines of stress on that tube. Whereas I suppose if we put it 90 degrees and locked it there, that puts the stress along the neutral axis. Probably less likely to break that way. Standard pinned Heim joints essentially on each end. So that is free to essentially rotate and pivot. So there are pinned columns on both ends essentially. So I'll throw the camera on the tripod here quick and just kind of give you a rundown of the motion, and then you can see it closing the movable jaw, and then also I'm going to show how I can use it to pick up wood and split some chunks of wood here. So we'll get you set up on that and I'll give you a quick demo. Alright, so hopefully that gives you a little bit of an overview of how it splits the logs. I don't normally do it on a concrete pad here. That's just kind of a storage area. So kind of a little bit more careful with it because I don't want to be digging the wedge into the concrete. And usually I'm dealing more so with the large chunks of wood like this guy. And then I get them sectioned down into smaller manageable pieces like that. But stuff like this, yeah. You're not going to get that up into a standard log splitter by hand, and you'd spend a lot of time farting around with it otherwise. So having the attachment on the back of the backhoe allows me to pick up, move around those big chunks of logs much easier because I can grab them and then cut them up into pieces with the chainsaw, and then they're manageable sizes. And for the really big round ones, I just work on splitting them with this jaw here so that they're all manageable sizes. So I'm going to pause here, get the tape measure, and we'll take some measurements. Alright, so this is the configuration I'm normally set at for the majority of the splitting. So the distance between the pins we have, right now essentially we're at 20 3/4 of an inch. The distance from the dipper stick pivot to the pin, we're looking at it's going to be 18.5 inches from here, and then the height above horizontal here is slightly adjustable. The pinhole itself is 3.5 inches above the center line of this steel bar, so there is a little bit of an offset in height there. And then from that dipper stick pivot up to the top link is 23.5 inches to here. And if we consider the boom as a vertical axis from the center, we're about 5.5 inches ahead of the center line to form this triangle here. The splitting wedge itself is 11 inches in total height here. So if we apply force down here, we've of course got a little more leverage arm trying to rotate this whole assembly up than if it's up on top. So where you apply your force on here will kind of determine how much of that rotational force you're going to have to stop with the top link. So you probably want to load it, kind of consider worst case scenario at the bottom of the splitting wedge, I would guess. We can get I think it was 33 inches I can sneak in there between the fully open jaw and the splitting wedge. I do have the splitting wedge at a slight angle from vertical, just because it makes it a little bit easier to get it started on the log. And then on here, the bottom, this is a 4-inch diameter heavy thick-walled round that's welded in on this jaw. So as this jaw comes around, the log kind of rides on this round portion. It's completely welded in edge, so I'll just give you a view from that side here. So there's a tube inside here that's like a 1/2-inch wall tube welded in that matches the outer diameter essentially of this radius, and then as it rotates in, the log kind of rolls on it and pushes it all in. So I showed how I can stand up the back of the backhoe, both on the rotating jaw in the back, as well as I can actually put all the weight of the backhoe onto this splitting wedge here, and then lift up the whole back of the machine. And so the backhoe itself is just shy of 14,000 pounds, and when we're set up to split, I usually have the outriggers out, and then the wheels are usually pretty much off of the ground, so they'll be in the air, can rotate. And so when I pick up the backhoe, either on purpose like I showed before or inadvertently, the 14,000 pounds of backhoe is pivoting on the edge of the bucket here. Right now it's kind of more on the back of the bucket than the front, but it pivots on there, and then I'm lifting up the 14,000 pounds by a point usually about 6 foot behind back here. So there's a lot of force on those either both the jaw and the splitting wedge and that top link when I pick up the whole backhoe, and essentially all of the weight that it's supporting when I pick it up on the splitting wedge ends up going through this top link to support the weight. So you'll be dealing with some pretty good sized forces that it takes to break those things. So if there are any other questions, of course, feel free to ask me. I can get you other measurements. I suppose I'll get you the H-link measurements too quick. Just because if you do analyze that, that will come into play. So this distance, you're looking at 16 3/4. And then your H-link distance is 15 inches. So if you start to play around with those dimensions, you can kind of build yourself a couple triangles and trapezoids in SolidWorks, and then just play around with the angles, and then you'll be able to figure out kind of how much force and what the angles are between all the links. And probably could just assume the splitting wedge as horizontal, and then maybe kind of consider this vertical, and then adjust the length of the top link to where it needs to be. But I'll let you guys figure that one out, but I'm here if you have any questions, so have fun. Alright, one last thing, I realized I didn't give you the distance from the dipper stick pivot to the lower, or the pivot of the link here, and so that distance is 10 inches. So with that information, now you can create a trapezoid between those 4 pivot points, and then a triangle between these 3 pivot points, essentially, and then play around with angles and forces as required. I'd sent in an email the hydraulic force is 2,150 psi, and that's a 3 1/4 inch diameter ram, which, as I recall, was something around like 18,000 pounds of force on that link setup. So that gets you started on if you need to analyze any of the forces that can be provided by the hydraulics. But I've never broken the link per se just based on hydraulics. It's always when there's a log inside here at some point that's a real hard to split log, that will let it break that top link. But I've stalled it numerous times without breaking the link, and then all of a sudden one time it'll break. So I suspect the high forces and the cyclic loading eventually fatigues the metal, and so should be an interesting piece to analyze in that regard. So, all right, if there's any other measurements that I forgot, let me know. I'll get them ASAP.